This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on antiderivatives. So here's the basic idea. We want to construct a function for a given derivative. In other words, we know the derivative, we want to find the original function. So can we find a function whose derivative is f prime of x equals 2x? And the first thing that comes to mind, of course, is f of x is x squared. The derivative of x squared is 2x. But is that the only function whose derivative is 2x? Certainly not. We could say x squared plus 4. The derivative of x squared is 2x. The derivative of 4 is 0. So x squared plus 4 would work. We could say x squared minus 3. Again, derivative of x squared is 2x. The derivative of minus 3 is 0. So you recognize there's an entire group of functions whose derivative is 2x. It's anything of the form x squared plus some number plus some constant. So the general form we say is f of x is x squared plus c, where c is an arbitrary constant, any number. Now the notation that we use for this antiderivative is this s symbol, or integral symbol. So the antiderivative of 2x dx, the integral of 2x, is x squared plus a constant. That is a family of functions, x squared plus c, whose derivative is 2x. Now for derivatives, we recall that the derivative of x to the n was nx to the n minus 1. Like the derivative of x cubed is 3x squared. Derivative of x to the 7th is 7x to the 6th. To reverse that process, the antiderivative of x to the n is x to the n plus 1 divided by n plus 1 plus c. This is going to be a very important rule for us to use. So looking at that, our first example is going to be the antiderivative of x to the 4th with respect to x, or the integral of x to the 4th with respect to x. Kick up the exponent by 1, x to the 4 plus 1 over 4 plus 1 plus c. That's x to the 5th over 5 plus c is what we get there. Let's look at another example. How about the antiderivative of 1 over x to the 7th dx? Now given our power rule, we want to write 1 over x to the 7th as a power. That of course is x to the negative 7. Then we kick up the exponent by 1, x to the negative 7 plus 1 over negative 7 plus 1, plus c, plus any arbitrary constant. So we get x to the negative 6 over negative 6 plus c. Rewriting that, that's 1 over negative 6 times x to the negative 6 plus c, which is 1 over negative 6. Remember, x to the negative 6 is 1 over x to the 6th. So my final answer is 1 over negative 6 x to the 6th plus c, or as we prefer, negative 1 over 6 x to the 6th plus c using the power rule. Let's try one more. How about the antiderivative of the square root of x? To use the power rule, we have to rewrite the square root of x as a power. And the square root of x is x to the 1/2 power. So with our rule, we increase the exponent by 1 and divide by that same new number. So it's x to the 1/2 plus 1 over 1/2 plus 1 plus c. 1/2 plus 1 is 3/2. So we get x to the 3/2 over 3/2 plus c. But dividing by 3/2 is the same as multiplying by 2/3. So indeed we get x to the 3/2 times 2/3 plus c, or 2/3 times x to the 3/2 plus c, written that way. 2x to the 3/2 over 3 plus c is a little cleaner. Now we've got some rules. Like the derivatives, we can pull constants out in front of an antiderivative. So the antiderivative of k times f of x is k times the antiderivative of f of x. So if I want the antiderivative of 7x squared, we'll pull the 7 out in front. So that's 7 times the antiderivative of x squared dx. But now we know how to do this with our power rule. That will be x to the 2 plus 1 over 2 plus 1 plus c. So 7 times x to the 3rd over 3 plus c, which we'll write as 7x to the 3rd over 3 plus c. Let's look at another one. How about the antiderivative of negative 6 over x to the 4th with respect to x? We're going to pull the negative 6 out in front. And then we want to use our power rule, so let's rewrite 1 over x to the 4th as x to the negative 4th. And then we use our power rule, x to the n plus 1 over n plus 1, x to the negative 4 plus 1 over negative 4 plus 1, all multiplied by negative 6. So that's negative 6x to the negative 3rd over negative 3 plus c. But negative 6 over negative 3 reduces to 2. So we get 2x to the negative 3 plus c. But what does x to the negative 3 mean? 1 over x to the third. 2 times 1 over x to the third plus c. That, of course, is 2 over 1. 2 over x to the third plus c will be our final answer for that one. Our next antiderivative rule is that the integral of the sum is the sum of the integrals, where the antiderivative of f of x plus g of x with respect to x is the antiderivative of f of x dx plus the antiderivative of g of x dx. So if I want the antiderivative of 5x squared plus 9 square root x dx, it's the antiderivative of 5x squared plus the antiderivative of 9 root x dx. Then we can pull the constants out in front, so it'll be 5 times the antiderivative of x squared dx plus 9 times the antiderivative of the square root of x dx. Next, let's pull the constants out. That'll be 5 times the antiderivative of x squared dx plus 9 times the antiderivative of root x dx. Antiderivative of x squared will be x to the third over 3. Kick up the exponent by 1, divide by that. Antiderivative of x to the 1/2 is x to the 1/2 plus 1 over 1/2 plus 1. This first piece is x to the third over 3. That piece is x to the 3/2 over 3/2. 9 divided by 3/2 is the same as 9 times 2/3. 9 times 2/3 is 6. So 5x cubed over 3 plus 6x to the 3/2 plus c will be our answer. Now there's a couple other facts that we know from the derivatives. The derivative of e to the x is e to the x. So the antiderivative of e to the x would be, going the other direction, the antiderivative of e to the x would be e to the x plus a constant. Similarly, the derivative of the natural log of x is 1 over x. So the antiderivative of 1 over x is sort of natural log of x plus c, except, of course, the domain of the natural log are only positive numbers. So we fix that by putting in an absolute value. So the antiderivative of 1 over x dx is just the natural log of the absolute value of x plus c. So if we're looking at this question, the antiderivative of 7e to the x minus 9 over x dx, antiderivative of the first piece minus antiderivative of the second piece, using that rule. The rule for the sum of functions, the antiderivative of a sum is the sum of the antiderivatives. Then let's pull the constants out. That'll be 7 times the antiderivative of e to the x minus 9 times the antiderivative of 1 over x dx. The antiderivative of e to the x is e to the x plus c. The antiderivative of 1 over x is natural log absolute value of x plus c. And that's the answer we get there. For our next question, we're going to look at the antiderivative of x squared plus 2x plus 5 times 3x minus 1. The antiderivative of the product is not the product of the antiderivatives. Just like the derivative of the product was not the product of the derivatives, we had a special rule. We don't really have a special rule for antiderivatives. We're going to need to multiply this whole thing out. So how is that going to look? Let's distribute x squared times 3x, 3x cubed, minus x squared times 1, minus 1x squared, plus 2x times 3x, 6x squared, 2x times negative 1 minus 2x, 5 times 3x plus 15x, 5 times negative 1 minus 5 dx. So distributing, we get this result, and then we look for like terms. 6x squared minus 1x squared is 5x squared. 15x minus 2x is 13x. And we're here. So we have the antiderivative of 3x cubed plus 5x squared plus 13x minus 5 with respect to x dx. Antiderivative of the first piece plus antiderivative of the second piece plus antiderivative of the third piece minus antiderivative of the fourth piece. And then we can pull the constants out in front. Pull the 3 out in front, pull the 5 out in front, pull the 13 out in front. For this piece, the antiderivative of 5 with respect to x. Think of a function whose derivative is 5 when x is the variable, and the answer to that is 5x plus a constant. So you'll notice I pulled the constants out here. The antiderivative of 5 with respect to x is just 5x plus c. To do this piece, the antiderivative of x to the third is x to the fourth over 4. The antiderivative of x to the second is x to the third over 3. That's, of course, x to the first power. The antiderivative of x to the first power will be x squared over 2. So there you go. 3 times x to the fourth over 4 plus 5 times x cubed over 3 plus 13 times x squared over 2 minus 5x plus c. And let's simplify this by writing it as 3x to the fourth over 4 plus 5x cubed over 3 plus 13x squared over 2 minus 5x plus c. And there is a slightly cleaner version of our solution. But again, the reminder, the antiderivative of the product is not the product of the antiderivatives. You need to do some algebra to express it as a polynomial, then we can go ahead and integrate each piece, take the antiderivative of each piece. And that will conclude this lesson.